Welcome to AI Frontiers, where cutting-edge research meets real-world impact. Today we're exploring 16 breakthrough papers published on August 1, 2025, taking you on a journey from deepfake detection systems to proactive AI safety frameworks. We'll discover how machines are learning to think, reason, and cooperate in ways that are reshaping our understanding of artificial intelligence. The future of AI isn't just approaching, it's happening right now. What makes this research collection truly special is how it captures 6 dominant themes that are shaping AI's immediate future. These papers span from explainable AI breakthroughs to multi-agent cooperation systems, with real-world applications transforming healthcare, education, and safety protocols. Rather than isolated technical demonstrations, these represent innovations with measurable societal impact, providing us with a comprehensive view of where artificial intelligence stands as we move deeper into 2025. Computer science. Artificial intelligence represents the science of creating machines that can think, reason, and make decisions in ways that were once exclusively human. We've evolved far beyond systems that perform isolated tasks to developing AI that understands context, explains its reasoning, and works collaboratively with humans and other AI systems. Today, artificial intelligence is woven into the fabric of our daily lives, from recommendation algorithms to fraud detection systems. This ubiquity brings new challenges around safety, interpretability, and effective collaboration, driving the field's evolution from proof-of-concept demonstrations to sophisticated systems that solve real-world problems. The first major theme revolves around explainable and interpretable AI, addressing what researchers call the black box problem. Consider a medical scenario where an AI system recommends a specific treatment. The system might be incredibly accurate, but without understanding why it made that recommendation, would you trust it with someone's life? This challenge is being tackled through frameworks like multi-SHAP, which explains how different types of information, visual, textual, and audio, interact within AI models to produce final decisions. Context-aware visualization systems are also making AI recommendations more transparent to everyday users on social media platforms. This theme reflects growing recognition that as AI systems become more powerful, understanding their decision-making processes becomes crucial for trust, accountability, and effective deployment in high-stakes applications. The second prominent theme centers on multimodal AI systems that integrate information from multiple sources like text, images, audio, and video to create more comprehensive and capable models. Think of this as giving AI systems multiple senses instead of just one. Humans don't just read text or just look at images. We combine information from all our senses to understand the world around us. Similarly, these multimodal AI systems can detect fake content across different media types by understanding patterns that span text, images, and audio simultaneously. They can also improve reasoning by grounding abstract concepts in visual information, much like how we might draw a diagram to help explain a complex idea. This theme highlights the field's movement toward more holistic AI systems that process and understand the world in ways that more closely mirror human perception patterns. Proactive AI safety represents our third major theme, reflecting growing awareness of the risks associated with increasingly powerful AI models. The Pro2Guard framework represents a paradigm shift from reactive safety measures to predictive ones, using sophisticated mathematical techniques to anticipate unsafe behaviors before they occur. In testing, this system achieved remarkable results, including 100% prediction of traffic law violations and collisions in autonomous driving scenarios, with the ability to anticipate risks up to 38 seconds ahead. Rather than simply reacting to problems after they occur, these systems can predict when they might be about to violate safety rules and take corrective action in advance. This proactive approach to safety could be revolutionary for deploying AI in high-stakes environments like autonomous vehicles or medical diagnosis systems. Our remaining themes explore advanced reasoning capabilities, specialized domain applications, and multi-agent cooperation systems. Advanced reasoning research reveals fascinating insights about how current AI systems approach formal mathematics versus informal problem-solving, showing they excel at coding tasks but struggle significantly more with formal theorem proving. In healthcare, AI frameworks are automatically extracting and synthesizing complex information from electronic medical records, potentially revolutionizing clinical workflows. Educational applications include adaptive learning systems personalizing educational experiences for students with diverse needs. Multi-agent cooperation research is developing theory of mind capabilities, creating AI systems that can infer what other AI systems or humans are thinking and planning. This represents a frontier area where AI research tackles some of the most complex aspects of intelligence, including social cognition and collaborative problem-solving. The key breakthrough findings from this research collection demonstrate transformative advances across multiple domains. Large pre-trained multimodal models naturally capture discriminative features between real and synthetic content, suggesting a universal approach to detecting fake media without requiring separate models for each type of generative system. Proactive safety enforcement systems can anticipate and prevent unsafe behaviors in AI agents before they occur, representing a fundamental shift from damage control to damage prevention. Theory of mind research demonstrates that AI agents can successfully infer others' beliefs and intentions solely from observable behavior, enabling sophisticated cooperation in collision avoidance and foraging tasks. Personalized explainable AI shows that explanation effectiveness can be dramatically improved by adapting both style and granularity to specific user needs. Finally, mathematical reasoning research reveals fundamental differences between how current AI systems approach formal versus informal problem-solving, providing crucial insights into current limitations and suggesting specific directions for improvement. The research methodologies employed across these papers represent the current state-of-the-art in AI research. Multi-stage large language model approaches address limitations of direct application by first extracting information, then constructing logical relationships, and finally generating tailored outputs. Multimodal learning explores different approaches to integrating information across modalities, offering the ability to capture richer representations while facing challenges in ensuring proper alignment between different types of data. Probabilistic modeling and statistical inference provide principled uncertainty quantification with theoretical grounding, though they can be computationally intensive. Meta-learning and continual learning methodologies enable AI systems to improve through experience without requiring parameter updates or retraining. Active inference and Bayesian approaches allow agents to maintain beliefs about other agents' mental states and goals, particularly powerful for modeling complex interactive scenarios. Our first paper spotlight features groundbreaking research by Tom Orr and colleagues in Unraveling Hidden Representations, a multimodal layer analysis for better synthetic content forensics. This work addresses one of the most pressing challenges of our digital age, detecting fake content across multiple types of media. Their revolutionary universal approach moves from specialized tools that work only on specific types of fake content to a system that can identify synthetic material regardless of how it was created. Rather than training specialized classifiers for each type of synthetic content, they leverage the latent representations of large pre-trained multimodal models, discovering that these models naturally capture discriminative information distinguishing real from synthetic content. Their experimental validation demonstrates state-of-the-art performance across audio and image synthetic content while maintaining computational efficiency. This approach offers a scalable solution critical for maintaining information integrity and public trust in an era of increasing synthetic media use for misinformation and deepfakes. Our second spotlight examines revolutionary research by Haoyu Wang and colleagues in Pro2Guard, proactive runtime enforcement of large language model agent safety via probabilistic model checking. This work fundamentally changes how we think about AI safety by shifting from reactive safety measures that respond to unsafe behavior after it occurs to proactive systems that anticipate and prevent unsafe actions before they happen. The methodology abstracts agent behaviors into symbolic states and learns a discrete time Markov chain from execution traces of agent behavior. At runtime, the system estimates the probability of reaching unsafe states in the future, triggering interventions when predicted risk exceeds user-defined thresholds. In household agent scenarios, Pro2Guard successfully enforces safety early in up to 93.6% of unsafe tasks while maintaining up to 80.4% task success rates. The autonomous driving results are even more impressive, achieving 100% prediction of traffic law violations and collisions with the remarkable ability to anticipate these risks up to 38.66 seconds ahead of their occurrence. Our third spotlight features Zhanling Wang and colleagues' work on multi-SHAP, a Shapley-based framework for explaining cross-modal interactions in multimodal AI models. This research addresses the critical need for interpretability in multimodal AI systems that have achieved impressive performance but remain largely opaque in their decision-making processes. The framework leverages the Shapley Interaction Index from cooperative game theory to attribute multimodal predictions to pairwise interactions between fine-grained visual and textual elements such as image patches and text tokens. Think of this approach like analyzing a complex musical performance where you want to understand not just how each instrument contributes to the overall sound, but how different instruments interact with each other to create harmonies and counterpoints. Multi-SHAP provides both instance-level explanations revealing synergistic and suppressive cross-modal effects for individual samples, and dataset-level explanations uncovering generalizable interaction patterns. Its model-agnostic nature makes it applicable to both open-source and closed-source models, requiring only access to model predictions rather than internal weights or attention mechanisms. Looking toward the future, several critical directions emerge from this body of research that will shape the next phase of AI development. The integration of proactive safety measures with explainable AI represents a particularly promising direction, potentially enabling systems that can not only predict and prevent unsafe behaviors but also explain their safety reasoning to human operators. This combination could be crucial for deploying AI in high-stakes environments where both safety and accountability are paramount. The development of more sophisticated multimodal reasoning capabilities presents another frontier, with researchers working toward AI systems that can seamlessly integrate and reason across visual, textual, audio, and sensory information in ways that approach human-level understanding. Theory of mind and multi-agent cooperation represent emerging areas with enormous potential impact, as AI systems become more prevalent in collaborative environments. The personalization of AI explanations and interactions presents both opportunities and challenges, requiring balance between personalization and transparency. Most importantly, the field is moving toward more holistic approaches that combine multiple methodologies and address multiple challenges simultaneously. This analysis was created using advanced AI synthesis and review processes to ensure accuracy and comprehensiveness. The content synthesis was generated using Claude Sonnet 4.0 for detailed analysis of the research papers and identification of key themes and breakthroughs. Text-to-speech synthesis is powered by Google's advanced text-to-speech technology to provide clear, natural narration. Image generation capabilities are provided by Grok AI to create relevant visual content supporting the research discussion. All content has been reviewed by human AI research experts to ensure technical accuracy and appropriate interpretation of the research findings. While every effort has been made to accurately represent the research, potential oversights are acknowledged, and all original research references are provided for verification. The analysis aims to make complex AI research accessible while maintaining scientific rigor and accuracy in the presentation of findings and methodologies. Thank you for joining us on AI Frontiers as we explored these 16 breakthrough papers from August 2025. Subscribe to our YouTube channel for weekly research updates and deep dives into cutting-edge AI developments. We provide expert analysis of breakthrough papers and trends, fostering community discussions about AI's impact on society. Be part of the conversation shaping AI's future. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archived preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses archived preprintserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archived preprintserver.org.